This is commentary from problem number 1 of class activity 8. So you were supposed to prove the proposition that the limit as x approaches 4 of 4x minus 3 over 3x minus 1 equals 1. So let f of x equal the fraction, and we need to bound the absolute value of the fraction minus 1 on the basis of the value of absolute value of x minus 4. And to do this, we simplify the expression f of x minus 1 first. And so we just do this algebraic manipulation here, so that now the absolute value of f of x minus 1 becomes the absolute value of x minus 4 over the absolute value of 3x plus 1. We need to bound it based on the absolute value of x minus 4. Now note that the numerator is the thing that we're bounding on the basis of. That is, we needn't worry about the numerator. All we need to worry about is the denominator, and we just need to bound it positively from below, because then that bounds 1 over it positively from above. Now the normal thing here is you stipulate an absolute upper bound on the thing you're allowed to pick an upper bound on, in addition to based on the epsilon. So if you do that and you use the reverse triangle inequality, you get the following. So I'll talk through it. We want to bound absolute value of 3x plus 1 positively from below, right? Based on the absolute value of x minus 4. Well, factor out an x minus 4 and see what's left. You get 3x minus 4 plus 13. And then here's where the reverse triangle inequality comes in. 3 times x minus 4 is assumed to be quite small. And so that's what you're going to subtract in your reverse triangle inequality. So absolute value of 13 minus the absolute value of 3x minus 4. Simplifying the absolute values a bit, you can take out the positive integers. And then the absolute value of x minus 4 is going to be less than delta, which is going to be less than or equal to 1. So it's bigger than 13 minus 3 times 1, right? Because when you subtract something, the inequality sign goes the other direction. And then that's just 13 minus 3, which is 10. So the absolute value of 3x plus 1, if we bound in this way, is bigger than or equal to 10. So 1 over it is less than or equal to 1/10. So therefore, if you bound the absolute value of x minus 4 by delta, and you stipulate the delta is at most 1, then the absolute value of f of x minus 1 becomes bounded by delta over 10. So in our proof, we're going to set delta to be the minimum of 10 epsilon, right? If delta is like 10 epsilon, then this becomes like epsilon, and 1. And now we're ready for the proof. See if you can put it all together before you go on to the next slide. Just take a second. Okay, so here's the proof. Proposition: the limit as x approaches 4 of 4x minus 3 over 3x plus 1 equals 1. Take an arbitrary positive epsilon. Let delta be the minimum of 10 epsilon and 1, as in our preparations. Take an arbitrary real number r, such that the absolute value of x minus 4 is between 0 and delta. And then you get the positive lower bound on 3x plus 1, as we discussed before. I've replicated it here, the same calculations. And from there, it follows that the absolute value of f of x minus 1, which is absolute value of x minus 4 over 3x plus 1, is less than or equal to delta over 10. But delta is less than or equal to 10 epsilon, so that's less than or equal to 10 epsilon over 10, which is epsilon. Voila.